So now that you have a brief introduction to the Python programming language, let's talk a little bit about the Pandas library. That's a library of Python functions that you'll be using a lot as a data scientist. So to follow along with me here, go ahead and find the pandas tutorial.ipynb file. That should be inside your course materials. You should be seeing something like this at this point. What is Pandas? Well, it's basically a way of processing tabular data. So when you have columns and rows of information, like you often do in data science, Pandas is a very easy way of loading that data in, manipulating it, examining your data, cleaning it up, and things like that. And it works together with two other libraries that you're going to be using a lot in the field of data science and machine learning. So when we talk about actual machine learning algorithms, we'll be using a Python library called scikit-learn, or sklearn for short. That's where it has all the actual code for doing things like linear regressions or SVM, all the stuff we're going to talk about later on. And that usually takes as an input a NumPy array. So NumPy is another library in the mix here that has its own representation of arrays of data. And those can be multidimensional arrays of data too. So it's sort of a way of representing information. So the way it usually goes is you might use pandas to load in your data and manipulate it and clean it up and understand it, and then translate that into a NumPy array that then gets fed into scikit-learn. And that translation often happens automatically, by the way. You don't have to do anything special. So what's more important at this stage is understanding pandas, right? Because actually feeding that into scikit-learn is pretty trivial. So let's talk about pandas. Let's scroll down here a little bit and play with some data, shall we? So we'll start off by importing what we need. So we're going to say that we want to use the matplotlib library in line. This line just means that any graphs that we create as part of our notebook will appear within the notebook itself and not within an external window. We then need to specifically import the libraries that we want to use in our Python code. So we're going to import the NumPy library as NP. That means that we can refer to NumPy as the shorthand NP within our script now. And we will also import the pandas library as PD. So this means that we've basically created an alias for the pandas library of PD just to save us some keystrokes. So let's go ahead and use pandas for the first time. What we're going to say here is df equals pd.read_csv pasthires.csv. So what's going on here is it's going to load up the pasthires.csv file. That's a comma-separated values file. That just means that it's tabular information where each column is separated by a comma. So it's just a very simple text-based format. And the first row usually corresponds to the titles of those columns. So with one line of code, we can read that data in from disk and create what's called a data frame out of it, a pandas data frame. And we're going to assign that data frame to a variable called df. So this loads in pasthires.csv and converts it into a pandas data frame. And then we can call head on that data frame object to visualize the first 5 rows of that data frame. And this is what it looks like. So let's actually click in here and hit Shift-Enter to run it. And you can see here, this is a little preview of the file. So if you just want to double check that everything loaded in correctly and understand what's in it, this is a good way to do a little spot check with head. You can see here that we have the first 5 rows being displayed here, and our columns are titled properly: years experience, employed, previous employers, level of education, top tier school, interned, and hired. We're going to be using this data set later on in the course to actually see if we can predict whether a job applicant gets hired or not based on their past history. Okay, so everything looks reasonably good there. You can also pass in an integer to head if you want to see some specific number from the beginning of your file. So if I wanted to see the first 10 rows of my data frame, I could just say df.head10 like that, and that'll print out the first 10 rows. You can see a little bit of a larger sampling of data there. And you can also look at the end of your data file as well, of your data frame as well. So df.tail will look like that, and that's displaying the last 4 rows in our data frame. You can see this is a very small data set. It's just something I made up. It only contains 12 rows of information. Now, sometimes we'll talk about the shape of your data frame or the shape of your data. And what we mean when we talk about the shape is just the dimensionality of it. So for example, if we say df.shape, that will come back with 13,7. And what that means is that we have 13 rows and 7 columns in our data frame. And that's the shape of our data frame, just how many columns it has, how many rows it has. Just a fancy word for a very simple concept. We can also say df.size, and that comes back as 91, which is just the number of cells in our data frame, basically the number of unique data points. And that's just going to be 13 times 7 in our example. 13 rows times 7 columns is 91. There's also a len operator. You can call len df, and that comes back with 13. That just gives you back the number of rows in your data frame if you just need that. And if you do df.columns, what that gives you back is an array of the actual column names. So if you want to do a little quick reminder of what your column names are and what they mean, That's a good way to like get a little quick visualization into what each column means. Sometimes you need to remind yourself, and that's a handy little trick. Now let's do some manipulation of this data frame. Let's say if we want to extract just a single column from that data frame. Let's say we just want to extract the hired column and do something specifically with that. Often when you're loading in data, you're not interested in every single feature that's in it. You want to extract certain features that you care about for the model that you're building. This is how that would work. So if I say df bracket quote hired bracket, that will just extract the first, that column, the hired column, as a single data frame. So we now have a new data frame that consists of just that single column, the hired column. And I could assign that to another data frame if I wanted to turn around and do that, and do something else with it. So I could say, hired column equals df hired or something like that. You can also extract a given range of rows within a column like this. So if I do df hired and then an additional bracket with :5, that will extract the first 5 rows of the hired column. And I get back a new data frame that looks like that, just 5 rows of the hired column and nothing else. So you can see how pandas can be used to sort of extract the data that you care about when you're trying to pre-process your data. You can also extract a single value like that. If I were to just say bracket 5 at the end, that's explicitly plucking out the hired column on the 5th row, which happens to be the value y. Okay, so let's talk a little about terminology here. Okay, we have a data frame. That's basically a multi-dimensional object, in this case a 13 by 7 object. And then when we extract a single row or a single column like this, that's going to give us back what's called a series. Okay, so that series is basically a 1D array. And if we extract a single value, that's usually referred to as, well, a value. So a little bit of terminology there. You can also extract more than one column if you want to. Obviously, that's going to be a more common situation. You would do that like this. So instead of passing in just a single quoted column name, you could pass in an array of column names instead like this. So we're going to say df bracket, and then we're going to have another layer of brackets inside those brackets that represents the array of column names that you want. So we're going to say df bracket bracket, years experience, comma hired bracket bracket. And that will give us back this new data frame here that consists the years experienced and hired columns and nothing else. And obviously you can add more columns to that list if you want to. So, again, a very common operation to extract only the features or the columns that you actually care about for a specific task. The less data that you push around, the better. So that's usually the first thing you want to do. Get rid of the stuff you don't care about. Okay, you can also extract ranges of rows from more than one column in the same way. So I could say I want just the first 5 rows of the years experienced in hired columns like this. Nothing too surprising in the syntax there. If you want to sort your results, sort your data frame, you can do it like this. There's the sort_values function you can call on data frame. Just pass in an array of the column that you want to sort by. And we'll say in this experience we want to sort by years experience. And you can see it did in fact do that, sorted from lowest to highest, 0 up to 20 years of experience in our little fabricated data frame here. What else can we do? We can also do value counts. That's the way of breaking down how many of each unique value exists, which can be a useful way to visualize your data. Kind of look for weird values that might be outliers. All you need to do is say df and then the name of the column that you want to count on, .value counts, and that will give you a count of each unique value within there. So make it real. Let's say we want to create a value count series out of the level of education column in our data frame. And then we'll go ahead and print that out by just saying degree_counts. And we get back this result, which indicates that in our entire data frame, there are 7 BS degrees, 4 PhD degrees, and 2 MS degrees. Okay, so, and if you want to, the tempting thing to do here is to create a histogram, right? So if we want to plot that distribution, that's very easy in Pandas as well. We can just say degree counts.plot, kind equals bar. So that's saying we want a bar plot of those degree counts. And since we used matplotlib inline way up at the top, that just go ahead and displays within our IPython notebook. So very easy to actually make graphs using Pandas as well. All right, if you want to practice this for yourself, I have a challenge for you. Get your hands dirty here and get a little bit of hands-on experience. Try extracting rows 5 through 10 of that source data frame of the potential hires that we have. And I want you to preserve only the previous employers and the hired columns. Assign that to a new data frame object, and then create a histogram like we just did here, plotting the distribution of the number of previous employers within just that subset of the data. Okay, so that should allow you to sort of put together all the stuff we talked about here. There's a lot more to pandas than this, obviously, but these are the most common operations that you'll need to deal with, and pretty much everything you need to know to get through this course and understand what's going on. So have a crack at that exercise. I think it'll be good practice for you. And with that under your belt, we can move on to some actual data science.